All right. Well, thank you all for coming again this month for the next Industry Lunch and Learn. We're doing the Internet of Things, and our presenter is Rick Earls. He is the Senior Director at Team Neo for the Smart Devices and Systems Cluster. He's got over 30 years of experience in technology-based business growth. He's authored more than 50 technical articles, papers, and reports. He's got 2 patents out. He is the former executive director at, it's not how it looks, it's Canius.
You got it.
All right. Which is an international industry trade association. He's also managed the commercialization of harsh environments, MEMS and NEMS technologies as vice president at the Glennon Microsystems. And then he also has a Bachelor of Science in Electrical Engineering from the University of Wisconsin. And I will turn it over to Rick.
Okay. I co-lead the Smart Device and Systems Cluster along with Tim. You all know Tim. The key activities there, of course, are the first thing we're really working on at this point in time is the Smart Devices and Systems Roadmap. It's actually an IoT roadmap. Also working with we've already established some working groups then too, so I'll be working with both the Smart Manufacturing Working Group and also the Smart Healthcare Working Group. We do, once in a while, we go out and do tech scouting. In other words, we go to conferences and find what the most recent developments are and innovations are, make sure we bring that information back for some of our key members. Also interviewing companies and learning about their technical capabilities, because we're going to be trying to put all that information into a framework, eventually doing a matchmaking type activity. Establishing partnerships with YBI, for example. They're helping us also go after, for example, how to drive demand. They're helping us go after both supply chain and demand side to find people in the region that want to focus on IoT. Also in the process of establishing an IoT audit committee, so that when we find somebody who wants to implement IoT in their manufacturing operation, we can actually bring in some experts, have them do a site visit, and then make recommendations as to what would make most sense. And then also, I'm part of the Neo Ready and Train partnerships. Both of those are part of the LCC, our relationship with LCC. The Neo Ready, of course, is a little bit more focused on companies that are part of the digital transformation. And then, of course, Train is more skills and workforce oriented. So, we're going to start off with what is IoT, and you'll see that we'll transition into IIoT. So sit back, get ready for the ride. Here's IoT. So basically, IoT is a bunch of smart devices all interconnected. You'll see that most of these are indicated that they have the ability to communicate, but this is a smart device.
Cell phone.
Oh, cell phone. I'm showing a cell phone. And it's a good example of a smart device. Again, it's got the ability to create data and then communicate it and coordinate its activities with other entities that have cooperating, or in fact, this is our we came up with a nice connecting smart devices in order to continuously improve efficiency and performance, emphasizing efficiency and performance of cooperating systems through the application of cognitive services. In other words, things like software, artificial intelligence, that kind of thing. Right? Now, here's an overview of what the potential for IoT is. This came from McKinsey, and it's broken down into 2 areas, which are important. So this is the supply side. In other words, these are the people who provide products that are sold so you can implement IoT. And these are the organizations, or at least these are the market segments that then use IoT to improve their business operations. All right? So that's the difference between supply and demand side. So we drive the mind here, and we also then interface with organizations like, well, this is where, for example, on the supply side would be Rockwell, would be Eaton, Allen Bradley, Siemens, some of those other guys. On this side, of course, are the people like Timken, Arconic. Those are the people actually or Lubrizol, trying to implement the capabilities within their own operations. All right. Now let's transition into IoT. In other words, that's the industrial Internet of Things. So that's why the extra I comes in. But it really refers to some of these other terms you've heard, I'm sure, in the past. Industry 4.0, it's probably the most popular one. Smart manufacturing, digital manufacturing, IoT all seem to work together. And so let's use the Industry 4.0 as a way of talking about it. So frankly, it's the background for IoT has been around for a long time. It really started back in the first industrial revolution. That's where we started using water and steam to actually power our machines so we could do manufacturing. Then we went on to manufacturing assemblies, started using electric, gas, water, and telegraphs to actually bring the supply chains together and do organized assembly. The third revolution, of course, is electronics and PLCs. This is when we actually got electronic controls involved in the machine design and in the part of the processes. And then in the Industrial Revolution, the one we're talking about now, 4.0, again, we've got smart devices connecting to each other, working through the cloud, and things like robots, mass customization, product as a service, all of those new concepts come together. All right. Okay. Now let's talk again. Here's more of a pictorial of IoT, and in fact, our friends told us also. We work with the Internet of Things Consortium, and they had a study created for them. Latherman Group did it, and this is one of their statements, and I think it's really indicative of, gives you a greater understanding what IoT is. It says marry advanced manufacturing techniques with the IoT. Remember, we saw that in the previous slide, to create digital manufacturing enterprise that is not only interconnected, but communicates and analyzes and uses information to drive further intelligent action. And so here's, again, a pictorial. So I've got a number of different stations along the manufacturing line. All of the sensors and everything and controllers are communicating to each other, going back to even a real-time dashboard in the planning area, and also then coordinating, for example, supply chain, and also, again, even some of the vehicles that are used then to distribute the equipment throughout the plant. Now, why do you want to do this? Why does IoT make sense? So here's a study that was done by Aberdeen, and it shows then, if you look at the revenue growth percentage, if I use IoT, I could experience an 18% growth. If I do not use IoT, they found out, again, by looking at, 472 different companies, they found that the companies only experience on average an 8% growth. So there's a 10% spread between using IoT and not using IoT. So the same thing then comes to operating profit. Here's another 7% spread. I'm better off using IoT. On cash flow, here's another 7% spread. And then the improved operating cost, of course, here's at least a 3%. So if I'm a big company, I'd like to see those numbers, right? Yes. All right.
Hey, Rick, I have to be honest. I'm still not sure I understand the difference between IoT and IoT.
One's industrial,
yeah,
and the other ones could be any number of applications, like commercial applications or consumer applications. So we're only fixed on industrial IoT, and typically that's inside the plant.
Okay, so IIoT is always going to be related to a manufacturing environment.
That's correct.
Okay.
Now, this is an eye chart, so I want you to all try to squeeze your eyes and see if you can do this. Now, the only reason I put this up here is because it actually is it defines the architectural levels that are pretty common when anybody's describing an IoT based system, and it's normally made up of an application level. Ignore this for a while. It's made up of an application level, systems level, communications level, and we call this the smart device level. Other people call it the hardware level. And then you'll see that at the application level, we're talking about things like deep learning, basic analytics, all that stuff up there at the top, and it's more application specific. So if we're looking at manufacturing, for example, I'm doing some unique stuff in the back of the plant, doing the analysis, trying to figure out what would be the best way of improving some of the performance and efficiency within the plant. Systems level. So at this point in time, basically that's taking the data that's been collected from all my smart devices and storing it. So things like cloud or VPN, those terms all come to life. Communications level. So at this level, that's, again, communicating either wirelessly or tethered, pulling data back from all my smart devices and whatever that infrastructure is needed to handle that. Again, the data acquisition is basically at this communication level. And then, of course, smart devices, all you have to do is remember here is these, at the hardware level, I got a phone again. This phone is useless unless it has software that tells it what to do. But at the end of the day, the only way this took off is because we drove the cost out and made it available for everybody and gave it a higher functioning capability. So I'm putting the phone down now. Going back to the talking about smart devices, that's exactly what we're doing here. In fact, as time goes on, you will not see these complicated pictures anymore because it will all look like this. They will all be totally integrated with the higher function capabilities, and there'll be things like here's smart motors, smart light bulbs. Everybody's had a chance to work with some of those, right? Even wearables. Some of you've got Fitbits and things like that on. Those are all examples of how these all then get totally integrated, and you'll start seeing that, again, this will be all totally a small representation and be easier as time goes on as we drive costs out and make sensors more ubiquitous. The only way this all works is if I send the sensors everywhere I need to and start pulling data in and start recognizing new relationships between all those different sensor implementations. Now, the reason this is here too is to emphasize that this is complex. The relationship that's necessary to bring a complete solution to bear has to be with the cooperation of people who create hardware, the people who make software, communications, data science, and security. All those have to come together as a highly integrated approach. In fact, you can see by looking at these colored squares that no matter what level I'm talking about here, technology level I'm talking about, everybody basically plays a role and has to be highly integrated if we're going to be successful. And that's one of the challenges for the cluster, and for that matter for this region, is how to bring all those different skill sets together and get them to cooperate. So why is IoT important for Northeast Ohio? We've seen this before. So this chart shows, again, the driver industries for Northeast Ohio. And then we also then selected the different technologies we thought could impact the region here. And as we've talked about in the past, the IoT-related technologies are smart healthcare and smart manufacturing. So if you look at both of those, take a look at the X's, it pretty well drives most of the driver industries, and that's why it became so important. Again, it was obvious that we wanted to work in those two areas, along with the others. But again, from an IoT standpoint, that's why these things are justified. All right, and then this is the big IoT bubble. If you notice, there's a whole bunch of alphabet soup in here. Those are all the different ones you'll be able to see. These smaller bubbles are the ones that mean the most to this region here. Now, the only thing is there's no way we have enough resources to handle all those at once, so we went with the ones that we thought would have the greatest impact, low-hanging fruit. So we went after smart manufacturing, and then we took these three bubbles, smart manufacturing, digital manufacturing, Industry 4.0, and combined them together. Remember we talked about that in that, 4 slides earlier? They are really the same thing. So we call it the same thing. So smart manufacturing is what we call those three bubbles, and that's what we're focused on now going forward with IoT. All right? This gives you a little bit of background before we leave smart healthcare. These, at least in this region here, smart healthcare is really more focused on wearables and then how that plays into pre-acute and post-acute care at this point in time. Now we're starting to work in acute care, but these are pretty good examples of what smart healthcare, what plays into the smart healthcare sector. All right? Now we won't talk about that anymore. We're going to talk about, again, the industrial Internet of Things, going back to that one slide we saw before. So again, it is a manufacturing line, a number of different stations all communicating with each other, and then all that information going back to a central processing place. The big thing we have to emphasize here, it is relative to all the other IoT applications, this is really real time. Manufacturing, the IoT has a basis of I make decisions when that data comes in, I make it real time, and I modify my behavior accordingly so I can maximize again my performance and efficiency. All right. Now, why did we want to do this? Again, why pick this? One of the reasons that drove us to pick this is that we've actually had a cluster around here for a very long time called Instrument Controls and Electronics. It's called ICE, and it's a legacy. So again, that's where basically the Rockwells go, that's the Eatons go, that's where the Parkers go. They're basically in this red squared out area. So we've been doing this for a long time. Now, as time goes on, we wanted to build on top of this. So that's where the additional software and communications capability comes in. We map that on top of it, and we have now a complete solution that builds on a strong base we already have in this region. And so we also then asked all those same people, how did they define IoT? What segments would they break it down into? So again, we got the ABBs. We even looked at some of the market studies and came up with these application segments. So supply chain management, operating efficiency, product quality, predictive maintenance, inventory control, and occupational safety. All right, we'll go here. No. So anyway, and then, so we took some of those things that were defined on the previous page, and we were able to find a study. I think this came from McKinsey. Yeah, McKinsey. And so they can show you, again, what kind of cost reductions in operating optimization you can experience, potentially, again, with the proper application of IoT. 5 to 12.5% cost reduction. Here's a 10 to 40% predictive maintenance, another big area that a lot of people are focused on. Inventory optimization, 20 to 50% reduction. Health and safety, that's another big area, 25%. So again, that's not to say that we haven't been doing these for years. Optimization, operations optimization is the fundamental of any business. Same thing with predictive maintenance. They've been doing, but it's not been predictive maintenance in the past. It's been planned maintenance. It's the same thing as changing the oil in your car. Somebody tells you I got to change it every 3,000 miles. Not necessarily. So now we want to go to a predictive point where you actually look at the conditions and then make decisions based on that. Inventory optimization, same thing. Do I have a lot of in-process stuff sitting in pallets next to all the different machines and it sits there for a month? And that doesn't make sense. But now that all the machines are coordinated and communicating with them, now I can do a better job of actually planning that process or planning that inventory as it goes through the whole plant. Health and safety, this is a big area then too, because now insurance companies will actually recognize your efforts to improve the conditions which your workers are in. And again, because I'm communicating all that information back, I can tell where the hazards are and how to defend people and prevent them from being exposed. All right, got a great slide here from Sydney, did this. So here's another big telltale as to what we can expect from, at least from Northeast Ohio, how this will impact business in this area. So right now, we looked at, again, the GRP for manufacturing, and this is how it was mapped without any influence of IoT. All right, so this is what we could expect in growth. So it's 49 billion in 2025. But if we just do a slight impact of IoT or start just rolling it out in the infancy, we should be able to get at least another 2.6 billion. Or now if we also go out of our way to put the required projects and programs in place and relationships amongst all the different contributors in the region, and we start working with our base, our membership base, we should be able to achieve another 62.6 billion in Northeast Ohio alone. So that's an increment of what, 16? So big impact. So it does make sense for us to go and put some extra effort in putting some of the resources necessary to make sure we can drive demand, and then we take advantage of our supply chain in this region. All right. And here's some of the companies that actually in this Northeast Ohio that play in the area. Just like I said, Rockwell, Parker, Eaton, and these are some of the concepts they're pushing on a regular basis, even GE, even small companies like Entwine and Tiny Circuits, all these other guys over here, Siemens Logistics, another small company. So you see it's a pretty good blend. Remember how many of those skill sets we were talking about, hardware, software, communications, and data security? That's where they all play. And here's a quote we got from one of our big guys in the region. We can't tell you who it is, but our company has identified 120 use cases and 50 million of potential EBITDA. Everybody understand what EBITDA is? Earnings before income tax.
Before interest.
Amortization, yeah. All right.
Depreciation, amortization.
See, everybody looks good. Available through Internet of Things applications. Knowing where and how to start is the challenge. All right. How will we help NEO adopt IoT? All right. So we started up a cluster called Smart Devices and Systems. And again, the members are basically from the supply chain and also from those entities that want to implement IoT into the back, or in this instance, IoT in the back, and any of those institutions that are already playing that area, the academics, and for that matter, we even have a federal lab here, right? Scope. Work includes developing the materials, components, device hardware, software, communications. Remember, I showed you that on that one big eye chart that everybody plays in that area. Build upon previous Flex Matters flexible electronics cluster. Remember, since 2010, we had a cluster created, and they were working on flexible hybrid electronics. And again, I'm holding a phone. This thing would not be here today if we had not created, or we didn't have an infrastructure for flexible electronics. The same concept applies to even smart devices. So we were able to build on that cluster activity and morph it into the Smart Devices Systems cluster. We do have a regional footprint, but frankly, if we see that there's a gap in the supply chain, we'll go anywhere we need to bring that member in so that we can provide complete solutions to those who actually need it, who have asked for the implementation of smart intelligent systems. Team NEO leadership is in close collaboration with regional partners. We got the jump starts. We've got the IOTC. We've got again Magnet, one of our biggest buddies. We've got NASA, So we're pretty well tapped to anybody who's got anything to do with controls and intelligence, embedded intelligence, and for that matter, even entrepreneurship. All right, and this is generally how we go about our business within the cluster. This is a general slide that applies to all the clusters. Again, so we have the global technology and market leaders in the region here in the middle. Then we have the other organizations, like I said, like research institutions, material suppliers, subcomponent manufacturers. That is support circle around the outside of that. And next to that then are our regional partners with regards to associations, public and private funding, economic development, all those other entities that then support the outside. Now, remember we had this from before, and I talked about a supply chain, and we also said we were focusing on manufacturing. Remember that? All right. And this is what our opportunity looks like. So again, here are the Rockwells, here are the Eatons, and all those guys. They make these products that then we're going to help all the manufacturers in our region take advantage of and start implementing within the Northeast Ohio segment. And again, I'm re-emphasizing this is the stuff we used to do and have been doing and doing very well in the past. But now we're also going to start adding a couple layers of software and data analytics. Yep.
So on that slide, you were indicating that we used to do this or have done this well.
Yeah.
But has it been integrated in the past to the degree that it needs to be integrated going forward?
Yeah. Now, as we go forward, we're actually asking more interchange of data and pulling more, in fact, also implementing more sensors, getting more of that information coming back, and then presenting it to these upper layers. But yeah, most of this was just in our machine-to-machine communications.
Right.
And it didn't really include all the extra data that we're using now to do a better job of analytics. And here's how, again, some of the companies that have been playing here. All over the map. MCPC, Parker, big guys, Blue Bridge. In fact, you'll start seeing a lot more names up here that have anything to do with analytics. We're really, in fact, we're finding a lot of organizations that do a lot with analytics. And also some artificial intelligence. We're finding a couple of organizations at that level. And then we also find some very good systems integrator. In other words, you saw that from that one eye chart that showed all the skill sets. How many different skill sets have to come together? Well, we're actually finding that we've got a number of different organizations that have put some of those skill sets together, or more importantly, have established networks, so that when they walk into their customer, they can represent a complete solution to the customer. And that's because they've established networks with other smaller companies that allow them to provide a complete solution. So, in fact, that's probably one of our greatest strengths now, is a lot of these organizations know each other relatively well and already have established pretty good, again, those critical relationships so they can provide complete solutions. And here's what we're going to be doing then, too. We saw this earlier, right? All right. So again, we're going to be doing what we can to drive demand for retention and expansion. So again, working with our partners, making sure that they're brought up to speed on all these advanced concepts, then going with them on calls. Of course, in the impact, we're going to, as I said, going after additional pushing know-how down to the lower echelons so that they can easily walk in and talk about some of these advanced concepts and show them how to apply it directly to their own operations. Leverage roadmaps that quantify these opportunities. That's the other thing. Again, giving that ability to our partners, a great tool. And then allowing even those organizations to be involved with the cluster going forward, because it just doesn't stop at what we're doing right now. It's a continuous process. It's a journey. It's going to take years before a lot of these advanced capabilities even make it through a plant, and you're going to see impact from it. And we have a collaborative framework we use to organize everybody's efforts. If you recognize these are the application level, the technology levels you saw from that other eye chart. And then what we've done is just take all those different application segments across there. So we bring them down where they intersect. That's where we call it a project. All right. So if I'm for example, if I'm a seeker like Arconic, in fact, we know for certain they really want to work on predictive maintenance. They need help in each one of these areas to be able, each one of these technology areas. They need help in that area to come up with a complete solution. They're trying to go from planned maintenance to predictive maintenance, and it's a real challenge. And so we'll be able to now, we take that same framework, we find all the capabilities, assets to all the companies that have capabilities in each one of these areas, and now we can match we can match Arconic's needs with all those different companies we're keeping track of. And that's part of the road mapping process. We're actually going to be taking profiles of all the different people we interview. And for that matter, as partners go on and they start interviewing the companies that are in their areas, then we'll be able to put them in that same matrix. So this just talks about the matchmaking process. So again, we have seekers' needs. Again, Arconic wants predictive maintenance. Solver capabilities. We have we've taken that picture. You saw all the different companies and their logos. We've quantified all their capabilities, put them in the database, and we can actually do a match. And the idea is to streamline that whole process to bring people together, get them to track those opportunities as quickly as possible, make sure they have the resources they need to go forward. Yep, so the roadmap's in progress, led by industry experts. Goal of the roadmap, again, is to identify supply chain. Just talked about that. Both the assets are the companies we already have, and then we'll also find some gaps. We want to fill those. Identify short-term, long-term, mid-term goals for the region, and then understand the digital maturity of each manufacturing segment. And the Smart Manufacturing Group is working currently on two different projects. One is a cybersecurity at the edge project. Again, we had a good-sized meeting, had a whole bunch of our members in the room, and they said, hey, we asked them, what do you want to work on? And all I asked was that one of them be a technology type application, the other one be a application vertical. And the first thing they said, let's talk about cybersecurity. It's a big issue, so we put a project together for that. And then, of course, the other one I've already mentioned, one of the application verticals is the predictive maintenance. So two projects there. And then we have another one for, now Smart Healthcare comes back. We have one for Smart Healthcare called the Smart ICU, Intensive Care Unit Project. And so here's some new things we're going to be having coming up. So second quarter, Smart Devices Systems Cluster Meetings, May 24th, you're all invited. Okay. And then, of course, save the date for the 20th. And we're going to have the third quarter cluster meeting at that point. And then if you're really interested, you can contact Melinda. And here's me. Here's Melinda. And here's Tim. All right.
Oh, that's just a lot of.
Yeah, that's just.
All right, so that is it for the presentation. Thank you, Rick. And next month we will have another topic. We haven't decided what it is yet, but we will have one.
Great.